Hello, we're Group 1. We're making a micro hydropower station. And our reasoning behind pursuing this direction was that in looking at all the different aspects of sustainability across the globe, we found that in many places there's up to 33.7% of people globally who don't have access to clean, reliable, and safe power, meaning that lots of it, if they even have access to it, is produced by dirty fossil fuels. And we also see that large power grids don't necessarily work with large decentralized populations, with a perfect example being in India, where there's more than 23 million people across 292,000 individual villages that don't have access to clean, reliable power. And so, lots of countries have decided that they want to try and tackle this by using dams and other large-scale hydropower projects. But, as of 2015, there have been 57,000 dams, and those dams have choked more than half of Earth's major rivers, which has huge environmental impacts, arguably more than that of just using fossil fuels in the first place.
Our response to this problem is an option for supplemental and sustainable power that can be used before more permanent solutions are implemented. For the scope of this class, and because of our limited time, we decided to narrow the focus of our project to be able to test in a controlled environment. We decided to focus on using small-scale hydropower to power a small electronic device, such as a smartphone or a battery pack, as a proof of concept for a real-world ready small hydropower system.
Our unique approach for this project is to use a Pelton wheel to generate our electricity. A Pelton wheel is a special type of water wheel that's an impulse water wheel as opposed to a deadweight water wheel that you might traditionally think of. An impulse water wheel takes the impulse from a highly concentrated jet of water and uses that to generate our electricity. In particular, the Pelton wheel has two cups that redirects the flow of water such that the dead water, the end result of the water, uses all of its momentum in the rotation of the wheel rather than flying off at high speeds.
The functionality of the project actually starts with the rotation of Pelton wheel that rotates an axle. And by using a belt connected with gears, we rotate the motor that's connected to a rectified circuit.
And in our regulator circuit, we have a 7805 chip, which is a 5-volt regulator, and we have two capacitors to smooth the flow of the voltage. And this circuit has been tested up to 30 volts, and it still regulates it down to 5 volts.
Throughout the development of this project, we ran into multiple barriers, one such being how we would connect and tension this belt assembly. What we ended up doing was just adjusting the height of this and then putting washers under this electronics box that could act as a tensioner for this belt. Additionally, we wanted to reduce the losses in the system as much as possible, so we added two bearings on both sides of the axle that could help and reduce the friction in that.